Hi everyone, welcome back to my channel. So today we are going to be discussing this topic, and that is differentiation. And here we are going to solve some questions from the A2 syllabus. So let's begin. So in the first question, we have been given the equation of a curve, and we have to find out the x coordinate of the stationary point in this interval, giving our answer correct to three significant figures. So whenever they mention stationary point, always remember that at this particular point on the graph, the gradient will be equal to 0. And if gradient is equal to 0, that means dy by dx will be equal to 0. So step number 1 out here will be to differentiate the equation of the curve given. So the equation of the curve that is given to us is y equal to cos x sine 2x. So to differentiate this, we can use product rule. So in product rule, the formula is what? The formula is dy by dx is equal to u dv dx plus v du by dx. Okay, so you can take u as cos x and v as sine 2x. So if we want to find out du by dx, so that is equal to minus sine x. And if we want to find out dv by dx, so that will be 2 cos 2x. So now we just have to jot down these data in this formula. So equal to u, which is cos x, into dv by dx, which is 2 cos 2x, plus v, which is given to be sine 2x, into du by dx, that is minus sine x. So now we can write it like this. So this will be 2 cos x cos 2x minus, this will become sine x sine 2x. Next, what we have to do is we have to use some identities. So the first identity that I'm going to use, that is sine 2x is equal to 2 sine x cos x. So using identity sine 2x is 2 sine x cos x. So what I'm going to do is I'm going to substitute this part with this equation. Okay, so let's do that. So this will become 2 cos x cos 2x minus sine x into, instead of writing sine 2x, we are going to write 2 sine x cos x. So this can be written as 2 cos x cos 2x minus 2 sine square x, because sine x into sine x into cos x. So next I'm going to use another identity, and that identity will be cos 2x is equal to 1 minus 2 sine square x. So using identity cos 2x is equal to 1 minus 2 sine square x. So again, what I'll be doing is I'll be substituting this cos 2x with this part. So this will become 2 cos x bracket 1 minus 2 sine square x minus 2 sine square x cos x. So now I can open up the bracket. So this will become 2 cos x minus 2 into 2, 4 cos x into sine square x. So sine square x cos x minus 2 sine square x cos x. So see over here we have minus 4 sine square x cos x minus 2 sine square x cos x. So this can become minus 6 sine square x cos x. So equal to 2 cos x minus 6 sine square x cos x. So from here we can take 2 cos x common. So step number next, so this will be 2 cos x bracket 1 minus 3 sine square x. Okay, so this is the expression for the first derivative that we got. So therefore dy by dx will be 2 cos x bracket 1 minus 3 sine square x. So we had to find out the x coordinate of the stationary point. So next step, at the stationary point dy by dx will be equal to 0. So we can now equate the expression for the first derivative to 0. So 2 cos x bracket 1 minus 3 sine square x will be equal to 0. So from here I can write 2 cos x is equal to 0 and 1 minus 3 sine square x is equal to 0. So cos x will be equal to 0 by 2, which will give us 0. So x will be equal to cos inverse of 0. Okay, and if you do cos inverse of 0, you're gonna get pi by 2. Okay, and here let's arrange this equation. So if I take 3 sine square x on one side, so this will become 3 sine square x equal to 1. Next, if I want to make sine square x the subject, so this will become 1 over 3. So when I take square root, I have to put a plus minus sign, and this can be written as plus minus 1 by root 3, because square root of 1 will give you 1. So remember, they had given us one interval, and the interval was from 0 to pi by 2. 0 less than x less than pi by 2. So let's write that down. So 0 less than x less than pi by 2. Basically, if we think of this in degrees, that means the value of x must be from 0 to 90 degrees. It should be greater than 0, but it should be less than 90 degrees. Okay, so if we draw a quadrant, so 0, pi by 2, over here we will have pi, 3 pi by 2, and back to this point, which will be 2 pi. So this is all positive, sine positive, tan positive, and cos positive. So since the range that is given to us is from 0 to pi by 2, that means we have to work with the first quadrant, and in the first quadrant all of these are positive. So here sine will be positive as well. So we have to take the positive value for sine, that is plus 1 by root 3, and we can ignore this other one, that is minus 1 by root 3. So using sine x is equal to plus 1 by root 3, we can now write that x will be equal to sine inverse of 1 by root 3. Okay, and one more thing, since they have given the interval in terms of pi, so our answer for x must be in radians. So whenever you use your calculator, please make sure that it is in radians mode. So here, as you can see, my calculator is in degrees mode, so I have to change that to radians mode. Okay, and I have done that. So let's find out the value of x. So it is 1 over root 3, and that comes to 0.615. And this is in radians. Okay, so if you look at our previous answer, we had got pi by 2, but see, according to the range, x should be less than pi by 2. It is not given like this. It is not x less than equal to pi by 2. If the question mentioned less than equal to, then we could have taken this other x value, but since it is x less than pi by 2, so this is out of range. and we have only one value for x, and that is x equals to 0.615 radians, and that is the answer for question number 1. So now we can move on to the next question. Okay, so here we have been given a diagram which shows a curve with an equation x by 1 plus 3x to the power 4, and they have said that all x values are positive and it has a minimum value of 0, and there is a maximum point M on this graph. As we can see, it's labeled, and we have to find out the x coordinate of M. So since it's a maximum point, that means it is a type of stationary point, and whenever we are given a stationary point, that means dy by dx will be equal to 0. So again, we have to differentiate this equation of the curve that's given to us. So let's do that. So let's jot down the data first. So equation of the curve is x by 1 plus 3x to the power 4. And in order to differentiate this, we can use the quotient rule. So according to quotient rule, so dy by dx will be equal to v du by dx minus u dv by dx whole thing by v square. This is the formula. So we can take u as x and v as 1 plus 3x to the power 4. So if we want to differentiate u with respect to x, that will come to 1, and if we want to differentiate v with respect to x, so that will be 12x cube. So once we have got these information, we can plug them in this formula. So equal to v, which is 1 plus 3x to the power 4 into du by dx, which is 1, minus u, which is x, into dv by dx, that is 12x cube, whole thing divided by v square, that means 1 plus 3x to the power 4 whole square. So if we simplify this, so this will become 1 plus 3x to the power 4 minus x into 12x cube will come to 12x to the power 4 divided by 1 plus 3x to the power 4 whole square. So see, 3x to the power 4 minus 12x to the power 4 will give us minus 9x to the power 4. So 1 minus 9x to the power 4 divided by 1 plus 3x to the power 4 whole square. So this is the expression for the first derivative, and at point M, which is a stationary point, this will be equal to 0. So we can write that down. So at M, dy by dx will be equal to 0. So 1 minus 9x to the power 4 by 1 plus 3x to the power 4 whole square will be equal to 0. So if we take this to the right hand side and multiply it by 0, we're going to get 0. So next step will be 1 minus 9x to the power 4 is equal to 0. So next we can write, if we take 9x to the power 4 to one side, so it will become 9x to the power 4 equals 1. So x will be equal to 4th root of 1 over 9. So let's see how much will that come to. So 1 over 9 to the power of 1 over 4. So let's see how much that comes to. Say it comes to 0.577. So this is the x coordinate of point M, and this is our final answer. Now let's move on to the next question. So here we have been given a curve with parametric equations, and this interval has been given to us. So we have to show that the gradient of the curve with parameter theta will come to this expression. So since we have been given x equal to tan theta and y equal to cos square theta, we can differentiate this with respect to theta. So this will become dx by d theta, and if we differentiate tan theta, it will come to sec square theta, and sec square is basically 1 by cos square theta. Similarly, over here we can differentiate y with respect to theta, and since we have cos square theta, so we can bring this 2 to the front, so 2 cos theta, and next when we differentiate this cos theta, this will give minus sin theta. So this can be written as minus 2 sin theta cos theta. Next, to find out gradient of the curve, that means we have to find out dy by dx. So we can apply chain rule. So applying chain rule, we can write that dy by dx is equal to dy by d theta divided by dx over d theta. Because if we change this to multiplication sign and flip this equation, so this will become d theta by dx. So this d theta and this d theta will get cancelled, and ultimately you'll be left with dy by dx. So let's do this. So dy by d theta we had got 1 by cos for dy by d theta we had got minus 2 sin theta cos theta, and for dx by d theta we had got 1 by cos square theta. So since we are multiplying this, so this will get flipped, so this will become minus 2 sin theta cos theta into cos square theta. So cos theta into cos square theta will give cos cube theta, and we will get minus 2 sin theta cos cube theta, and see this matches with the expression given to us in the question. So we have shown this derivation. Okay, now let's move on to the next question. So they have said that the gradient of the curve has a maximum value. The gradient has a maximum value at point P. So since the gradient has a maximum value at this point, so we can say that the second derivative of this equation will be equal to 0 at this particular point. Whenever the curve has a maximum point, the gradient or the first derivative is equal to 0. But if the gradient has a maximum value at this point, like they have said in this question, so the second derivative will be equal to 0, and we have to find out the exact value of the x coordinate of P. So first what we have to do is we have to differentiate dy by dx with respect to x and find out the expression for the second derivative. So dy by dx we had got previously from this part, it was minus 2 sin x cos x, this expression, minus 2 sin theta or cos cube theta, sorry. So minus 2 sin theta cos cube theta, and we have to differentiate this again. So what we can do is we can use product rule again. So let's take u as minus 2 sin theta and v as cos cube theta. So if we differentiate u with respect to theta, so this will give us minus 2 cos theta, because if we differentiate sine we get cos. And next when we differentiate v with respect to theta, so this will give 3 cos square theta, and next when we differentiate cos we will get minus sine theta. So this will be equal to minus 3 sine theta cos square theta. And if we apply product rule, So product rule, the formula again, it was, for this one it will be again u dv by d theta plus v du by d theta. So let's do that. So this will be u into this, so minus 2 sine theta into minus 3 sine theta cos square theta, plus then we have to do v into du by d theta. So this will be v cos cube theta into minus 2 cos theta. So if we simplify this, so this will become minus 2 into minus 3, that's 6 sine times sine theta will be sine square theta cos square theta, and this will become minus 2. Oh, one more thing, out here v is cos cube theta, so you don't have to write this v out here. So this will be minus 2 cos to the power 4 theta. So from here I can take cos 2 cos square theta common. So if I take 2 cos square theta common, in brackets I'm going to have 3 sine square theta minus cos square theta. So this is the expression for the second derivative. So d2y by dx2 will be equal to 2 cos square theta bracket 3 sine square theta minus cos square theta, and at point P, when the gradient has a maximum value, this will be equal to 0. So at P, the second derivative will be equal to 0. So I can now equate this expression to 0. So 2 cos square theta into 3 sine square theta minus cos square theta will be equal to 0. So I can equate 2 cos square theta to 0 and 3 sine square theta minus cos square theta to 0. So cos square theta will be equal to 0. Therefore, cos theta will be equal to 0. So theta will be equal to cos inverse of 0. Remember, they had also given us an interval and we have to use that interval in this question, and the interval was from minus pi by 2 to plus pi by 2. So let's write down the data as well. So minus pi by 2 less than theta less than plus pi by 2. Okay, see, there is no equal to sign out here. That means theta must be greater than minus pi by 2 but less than plus pi by 2. So if we do cos inverse of 0, we are going to get minus pi by 2 and plus pi by 2, and as we can see, both of these values of theta are out of range. So therefore this is out of range. So let's work with this part now. So we can take this cos square theta to the other side. So this will become 3 sine square theta equals cos square theta, or sine square theta equals 1 by 3 cos square theta. So now if I take this cos square theta and bring it to the denominator on the left hand side, so this will be sine square theta by cos square theta equals 1 over 3. Okay, so sine square theta by cos square theta is tan square theta. So now this will become tan square theta equals 1 over 3. So I can now write that tan theta is equal to plus minus square root of 1 by 3, and square root of 1 is 1, so this can be also written like this. Okay, so we have tan theta equal to 1 by root 3, and we have tan theta equal to minus 1 by root 3. Okay, so if I find out theta from here, so it's tan inverse of 1 by root 3, and from here theta will be tan inverse of minus 1 by root 3. So now let's calculate for theta. So for that we have to again bring out our calculator. So tan inverse of 1 over root 3, and that comes to pi by 6. So this will be equal to pi by 6. And if we do tan inverse of negative 1 by root 3, we should get, we should get 1 over square root of minus 3. So we should get minus pi by 6. Okay, so as we can see, both of these values are within this range. But let's look at the question again. So we have to find out the x coordinate of P, and where is P in that curve? So P is out here. That means this x coordinate should be a negative value because it is falling to the left of this y-axis. So, and also if we look at the equation for x, that is equal to tan theta. So tan theta, if it gives you a negative value, that means that is the value that we are looking for. So if we come back to our working, we will see that for this value of theta, we are getting a negative value for tan theta. So this must be the x value that we are looking for. So since x is equal to tan theta and this x must be a negative value, so we have to take theta as minus pi by 6 and x will be equal to minus 1 by root 3. So x is equal to minus 1 by root 3. This can also be written like this, minus 1 by root 3 into root 3. If you divide the denominator by root 3, you have to multiply the numerator by root 3 as well. So this will become minus root 3 by root 3 into root 3 will give you 3. So this will be your final answer for this question. So now let's move on to question number 4. So we have been given a curve again with equation root x cos x, and they have said that M is a minimum point. So again, this is a stationary point where dy by dx will be equal to 0, and at point M, x is equal to a. So we have to show that the equation a tan a is equal to 1 by 2a. So let's do this. So again, let's jot down the data. So y equal to root x cos x. So if we want to find out the first derivative, we have to differentiate this with respect to x. So at point M, dy by dx is equal to 0, and to find out the expression for the first derivative, we can again use product rule. So u will be equal to root x, which can also be written as x to the power half, and v will be equal to cos x. So if I want to find out du by dx, so that will be half x to the power minus half, and this can also be written like this, 1 by 2 root x, and when I differentiate this will be equal to minus sin x. So now let's apply product rule. So to find out dy by dx, the product rule is again u dv dx plus v du by dx. So u is root x into dv by dx, that is minus sin x, plus v, that is cos x, into du by dx, that is 1 by 2 root x. Okay, so this is the expression that we can get. So we can simplify this further. So if I multiply this side with 2 root x, so this will become 2 root x into minus sin x plus cos x whole thing divided by 2 root x. So this will become 2 into x, because root x into root x will give you just x. So this will become minus 2x sin x plus cos x divided by 2 root x. Okay, next at x equal to a, where we have our point m, dy by dx will be equal to 0. So at x equal to a, dy by dx will be equal to 0. So we can equate this to 0 and we can replace x with a. So this will become minus 2a sine a plus cos a by 2 root a equal to 0. So if we take it to the right hand side and multiply it by 0, this will become 0. So this becomes minus 2a sine a plus cos a equal to 0. So I can take 2a sine a to the other side. So this will become 2a sine a equal to cos a. So I can take this 2a to the right hand side and bring cos a to the left hand side. So this will become sine a by cos a equals 1 over 2a, and sine a by cos a will give us tan a. So therefore tan a will be equal to 1 by 2a. So see, this is what we had to derive according to the question. So shown. Okay, this is the working for this question. Moving on to question number 5. So here they have given us that the equation of the curve is 2 minus x e to the power minus half x, and again m is a stationary point. This time it is a minimum point. So here dy by dx will be 0 once again. So we have to find out the exact coordinates of m. So to differentiate this, we can do it by the product rule again. So u is equal to 2 minus x and v is equal to e to the power minus half x. So if we do du by dx, so this will give us minus 1. And if we do dv by dx, this will give us minus half e to the power minus half x. Why? Because if we have an equation like this, y equal to e to the power fx, so the rule that we use to differentiate this is first we differentiate this function. So this can be denoted as f prime x. Then we write down this expression as it is. So here if we differentiate minus half x with respect to x, so we will get minus half, and then we write this expression as it is. So now let's plug in these expressions in the formula. So dy by dx will be equal to u, which is 2 minus x, into dv by dx, that's minus half e to the power minus half, plus v, that is e to the power minus half x, into du by dx, that's minus 1. So if we want to simplify this further, we can take e to the power minus half common. Okay, so in bracket we are going to have 2 minus x into minus half minus 1. Okay, so let's see how we can simplify it further. So this will become, if minus 2 into minus 1, so minus 2 minus x minus 1, so that will be plus x by 2 minus 1. So e to the power minus half x, this will be minus 2 plus x, minus 1 into minus 1 into 2, that's minus 2 by 2. So see, this becomes e to the power minus half bracket x minus 4 by 2. So at point M, which is a stationary point, dy by dx will be equal to 0. So this is the equation for dy by dx that we got. So at M, dy by dx will be equal to 0. So we can write e to the power minus half x bracket x minus 4 by 2 equal to 0. So now we can write e to the power minus half x equal to 0 and x minus 4 by 2 equal to 0. Okay, so here if we take ln on both sides, so this will be minus half x ln e equal to ln 0, and if you check you will see that ln 0 is undefined. So that is why we cannot have a value of x from here. It will be a very large value. So here we can now find out the value of x. So now if we multiply 2 and 0, that will give us 0. And next when we take 4 to the other side, so we will get 4. So this is the x coordinate of m, because see m is on this side, so x will have a positive value. So next we have to find out the corresponding y coordinate of m, because they have said find the exact coordinates of m. So we have to find both the x coordinate and y coordinate. So we can just plug in the value of x in the equation of the curve given. So the equation of the curve that was given to us was y equal to 2 minus x e to the power minus half x. So when x is equal to 4, y will be equal to 2 minus 4 e to the power minus half times 4. So that will be minus 2 into e to the power minus, so minus half into 4 will give you minus 2. So minus 2 e to the power minus 2. So since they have asked for the exact coordinate, see, so we do not have to calculate the value for this. We can leave it in this form. So m is equal to 4 comma minus 2 e to the power minus 2, and that's our final answer. I hope all these explanations were clear. So this is the end of this video. Please leave a like if you've understood all the concepts, and don't forget to subscribe to my channel if you're new to this. Okay, thank you. Bye bye.